Hi guys, welcome to Chemistry 1001. We're talking about entropy change and the third law of thermodynamics. Here I want to just show you something very quickly, how to calculate the entropy change when something boils. Remember, the entropy changes vertically, it means that the temperature remains constant as the entropy increases whenever we have a phase change. In that case, delta S is very easy to calculate. Delta S is just the heat added to the system as it's converted from one phase to the other at the constant temperature, the temperature of melting or boiling, or whatever the phase change temperature is. Normally, if you add a bit of heat, the temperature changes, so you wouldn't be able to apply this formula because every time you added the heat, the temperature would rise somewhat. We can apply this formula exactly at phase change because the temperature doesn't change. So for instance, if we have 1 mole of water vaporizing, that's 417,000 joules per mole, and that happens at 100 degrees Celsius, which is 373 degrees Kelvin. Dividing that to, we get the entropy change of vaporization. This is negative delta H of vaporization divided by the temperature. It gives us 109 joules per Kelvin. And that's the entropy change of vaporization for 1 mole of water. Now, note that if we knew already the entropy change of vaporization, and if we knew the delta H, we could divide those two numbers and obtain the boiling point. So all of these quantities are related. Phase change temperature, delta H, and delta S. Now, it turns out that water has a rather high delta S of vaporization because water has a fairly ordered liquid. The liquid waters form hydrogen bonds, which makes liquid water a little bit more ordered than normal liquids would be. The entropy change of vaporization is actually normally about 85 joules per Kelvin, and this is known as Trouton's rule.